काहून याची घेऊन चालू होती ना कॅन्सल झाली का
आता आता ना तुझ्यावर वेळ लागलो तू घरी जाय
कोणतं काम असतं इथे कोणतं काम किती म्हणजे कार्टून करायचं राहा चित्र बनवायला की बरं त्याची पूर्ण त्या कॉलेज पूर्ण लावली बरं शोध आपल्याला हे म्हणजे गव्हासोबत ती म्हणते फळे असा कार्यक्रम आहे या
गर्नुले सर, हॅलो.
हा हॅलो मॅडम.
हा, गुड आफ्टरनून सर, कसे
गुड
आहेत?
आफ्टरनून. गुड आफ्टरनून मॅडम.
धडाधड घेत आहेत कॉन्फरन्सेस.
नाही.
सर, एक विमेन सायंटिस्ट किंवा विमेन इन रिसर्च, विमेन इन केमिस्ट्री रिसर्च, आणि लेट देम गिव्ह ऑपॉर्च्युनिटी फॉर अस टू एक्सप्लेन आवर रिसर्च.
ओके मॅडम.
येस
ओके.
सर, ऑल द बेस्ट सर.
ओके, थँक्यू.
कितीला चालू करतोय आपण?
3ला सुरू करतोय मॅडम.
बरोबर.
3ला.
ओके सर, ऑल द बेस्ट सर.
ओके. Hello, good afternoon, Professor Pade sir.
Yeah, good afternoon, sir. Very good
Good afternoon.
afternoon. Yes,
afternoon.
yes, yes. How are you, sir?
Fine, sir.
Yeah. It's really pleasant.
Professor Prabhu sir is not available, na?
Yeah. He was
He's out of
he has written. He's not available. No
Professor
problem.
Pade. Hello, Sonia madam. Hello.
Hello.
Madam, Professor Bijesh Pade, he is the president of the Association of Chemistry Teacher in India.
Oh, nice to meet you.
Hi. How are you, ma'am?
Fine, thank you.
Yeah. You recently, in Indore, a couple of weeks before, you spoke there, and I listened to you. Very nice. Yeah. Mm. In India
Oh,
also.
okay.
Yeah.
Thank you.
Indore. Yeah.
Yes, yes, also, yes.
Yeah, nice meeting you. Thank you for joining.
Oh, nice to meet you too.
Yeah.
Yes.
आर्या हे आर्या हे आर्या तिकडनं तू हे बघ डिस्कनेक्ट हो.
हेलो हेलो
Hello.
Hello.
हेलो
Hello.
Audible?
Hello. Hello, Malduri sir.
Welcome, Mahan sir.
Thank you.
Welcome, Chandan Bhatt sir. Welcome, Mansur sir. Hello.
Hello, Chandan Bhatt sir.
No, sir.
Good afternoon.
Hello. Hello.
Hello,
Chandan Bhatt
Rohini.
sir. Chandan Bhatt sir.
Okay.
Hello, Chandan Bhatt sir. 1 minute, sir.
Sir, good afternoon. Chandan Bhatt, sir.
हेलो महाजन सर. हेलो हेलो महाजन
हाँ
सर.
बोला.
हाँ नमस्कार सर.
हेलो.
नमस्कार सर. हाँ नमस्कार
Is
सर.
audible?
हो हो
नमस्कार.
ऑडिबल आहे सर, ऑडिबल आहे.
नमस्कार. ओके.
सर तुमचा माईक आणि व्हिडिओ ऑन करा ना. बरं बरं.
हेलो.
हॅलो हॅलो. हाँ बनसोड सर. पवार सर. हाँ बनसोड सर. पवार सर.
हो आहे सर मी.
सर आवाज येतो म्हणजे थोडासा वेगळा आवाज येत आहे. 2 ठिकाणून जॉईनिंग आहे का सर? सर पवार सर.
हो सर 1 सेकंड करतोय 1 सेकंड.
हाँ हाँ हाँ.
हाँ सर मालदर सर.
हाँ सर आता येतं क्लिअर सर.
हाँ ठीक. ओके ओके थँक यू.
चंद्रपाट सर माईक बंद आहे तुमचा. माईक बंद आहे. येस सर ना ओके. हॅलो सर. नमस्कार चंद्रपाट सर. हॅलो हॅलो.
Maldu sir, we can start at 3 o'clock.
चंद्रपाट सर आवाज येत आहे? सर आवाज नाही येत तुमचा. वन मिनिट सर 1 मिनिट. महाजन सर आहेत का?
Oh,
हाँ
I am there.
ओके थँक्यू सर.
नमस्कार सर.
हाँ नमस्कार सर. नमस्कार सर. नमस्कार दुपारी सर.
मालदुरे
एक
सर,
मिनिट सर, फक्त चंदन भट सरांचा
चंदन,
प्रॉब्लेम.
हाँ चंदन
हो,
भट
हो,
सर
हो.
का आवाज, सर इज नॉट ऑडिबल.
नहीं नहीं
दुसऱ्या फोनवर जॉईन होत आहे. हॅलो, वन सर 2 मिनिट्स. ते दुसऱ्या फोनवर जॉईन होत आहे.
ओके सर.
गावंडे मॅडम.
यस सर.
हा सर, 2 मिनिटांमध्ये जॉईन होतात.
ओके.
स्टार्ट. पवार सर प्लीज.
गावंडे madam, you are
Yes, sir. I am available.
हा
Yes sir,
okay.
I'm available.
Keep camera on, okay?
ओके.
Yes sir.
Hello, Dr. Chandan Bhatt sir.
हेलो हेलो, हाँ डॉक्टर. हेलो
Hello, Atish. Upulwa sir, good morning. Hello, madam. There is 1 or 2 minutes, okay, to start. And I'm giving some introduction. Professor here, Maldure is there, is the convener. Hello, Maldure sir.
Good afternoon, sir.
Can we start?
चंदन भट सर, माइक ऑन करा. माइक ऑन करा चंदन भट सर. सर विदाउट कॉर्ड ऑपरा तुमचा आवाज नाही येत सर. हॅलो सर, विदाउट कॉर्ड आवाज नाही येत तुमचा सर. विदाउट कॉर्ड ट्राय करून बघा. Hello, Gunnar sir. Hello, Gunnar sir. We can now start, sir.
Rohini?
Yes, sir.
Okay.
Yes, sir,
Start now.
because
Can I start, sir?
Yes, yes.
Good afternoon, ladies and gentlemen, and all dear students. It is my pleasure to be moderate for seminar. I am Rohini Gawande. I would like to extend a very warm welcome to all of you for our today's international webinar on innovation in science and technology 2021 on the occasion of Silver Jubilee Year celebration organized by Department of Chemistry, Srimati Narsamma Art Commerce Science College, Kiran Nagar, Amravati, and Association of
बरं सर तुमचा माईक बंद करा प्लीज.
Chemistry Teacher, Homi Bhabha Center Science Education, TIFR, Mumbai. It is my proud privilege to welcome you all to inaugurate this program. I would like to invite convener of this webinar session, respected Dr. Atish K. Maldhure sir, Department of Chemistry, Srimati Narsamma Art Commerce Science College, Kiran Nagar, Amravati, to deliver the opening remark. Over to you, sir.
Okay, thank you, Gawande madam. Good afternoon to all of you and good morning to Sonia madam. On behalf of on behalf of Srimati Narsamma Arts, Commerce and Science College, Kiran Nagar, Amravati, ACT and Organizing Committee, I welcome all the resource persons, academicians and participants for the international webinar. Can I audible, sir? Guru, sir?
Yeah.
Please.
Yes, yes, audible.
Yes, sir. Can you share screen? Can you share a screen, sir, please?
No, sir, you start your speech. Yeah.
Okay, okay, ठीक है, sir. I welcome all the resource persons, academicians, and participants for the international webinar on innovations in science and technology, organized by Department of Chemistry, Srimati Narsamma Art, Commerce and Science College, Kiran Nagar, Amravati, and Association of Chemistry Teachers to celebrate Silver Jubilee Year of Srimati Narsamma Art, Commerce and Science College, Kiran Nagar, Amravati, and National Science Day. Honorable Sri Ramji Mahajan, sir, Secretary of Srimati Narsamma Hiraiya Shaikshin Trust, Amravati, President of Honorable Sri Ramji Mahajan, sir, Secretary of Srimati Narsamma Hiraiya Trust, Amravati, President of today's inaugural session. Honorable Professor Brijesh Parekh, sir, President of Association of Chemistry Teachers and Professor and Head, Department of Chemistry, Madhav Science PG College, Ujjain, inaugurator of today's international webinar.
Thank you, sir.
Okay, madam.
Now
Madam, please continue.
Oh, okay, sir. Okay.
Madhav Science PG College, inaugurator of today's video. Speaker of today's program, Professor Sonia AC Carabinero, New University of Lisbon, Portugal. Professor Brijesh Parekh, President ACT, and Professor Vasudha Gurale, Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur. Principal of our college, Dr. Rajesh Chandanpad, sir. Dr. Srikant Bansod, Head, Department of Chemistry, Srimati Narsamma College, Amravati. Coordinator of today's international webinar, Dr. Mahendra Singh Pawar. And dear participants from the globe and from various parts of At first, I would like to make special mention of Sri Chandrasekharji Bhondu, sir, President of Srimati Narsamma Area Association Trust, Amravati. Though they could not join us, their blessing and best wishes are with us. Also, I special mention of Dr. Prabhu sir. I also extend a warm welcome to Honorable Sri Ramji Mahajan sir, Dr. Brijesh Pare sir, Dr. R. Chandampar sir, Dr. Srikant Mansur sir, and speaker of today's program. They oblige us by accepting our request to be present for inaugural session of international webinar on innovation in science and technology. There are many societies of material science which have made tremendous contribution to science and technology. Chemistry and chemical process have always had a major role to play in the development and use of material. Today, world needs innovations in science and technology. The main objective of organizing the international webinar is to provide a platform for interaction and collaboration among the eminent professionals, researchers and scholars of different fields from both academia and industry to discuss the innovation in science and technology. This webinar will be definitely beneficial to the participants in the field in general and young students in particular. For this international webinar, more than 3,500 participants have registered from different countries like Thailand, Philippines, China, Nigeria, Tanzania, Oman, Indonesia, Libya, Malaysia, United Arab Emirates, Pakistan, Romania, Albania, Sri Lanka, Bosnia, Myanmar, Afghanistan, Nepal, South Africa, Bangladesh, Uzbekistan, Egypt, Mexico, and almost all the states of India. So I welcome you all on this occasion. This year, the ACT has now completed the 2 decades of service to the chemistry community in the country and decided to organize different activities for the benefits of students and teachers in different zones. We have an opportunity to be benefited by the talk of Professor Sonia A.C. Carabinero, New University of Lisbon, Portugal, Professor Brijesh Pare sir, President of Association of Chemistry Teachers, and Professor and Head Department of Chemistry, Madhav Science PG College, Ujjain. Professor Vasudev Gurnale sir, Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur. At last but not least, I hearty thanks to the Professor Gurnale sir, because without him and without his support, I am unable to organize this international webinar. Also, I hearty thanks to my management members and my honorable principal sir, Dr. Rajesh Chandampar sir, because their support is with me always, so I am able to organize this international webinar. So at last again, I thanks as a convener. I thanks to all of you. I welcome all the resource persons, speakers, academics, and participants again, and thank you all.
Thank you, sir. Now, I would like to invite respected Dr. Rajesh S. Chandanpat, sir, Principal of Srimati Narsamma Art Commerce Science College, Kiranagar, Amravati. Please, sir, deliver your introductory remark. Over to you, sir.
Good afternoon, one of and all. On behalf of Srimati Narsamma Arts Commerce Science College, Kiranagar, Amravati, and Dr. Rajesh Chandampar, Principal of the college, extend warm welcome to all respected guests, scholars, participants, and faculty members on the occasion of inaugural function of an international webinar on innovation in science and technology, organized by the Department of Chemistry, Srimati Narsamma Arts, Commerce and Science College, Kiranagar, Amravati, is in association with Association of Chemistry Teachers, Mumbai, to celebrate Silver Jubilee of Srimati Narsamma College, Amravati, and National Science Day. On this dais, we have President of the Program, Honorable Ramji Mahajan, Secretary of Srimati Narsamma Area Shaikshanik Trust, Amravati, Chief Guest and Inaugurator of the program, Professor V.D. Prabhu sir, General Secretary of ACD, Wilson College, Mumbai. Speaker of the today program, Professor Sonia A.C. Carabinero, New University of Lisbon, Portugal. Professor Brijesh Pare, President, ACD and Professor and Head of Department of Chemistry, Madhav Science, PG College, Ujjain, and Professor Vasudev Gurnule, Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur, and Dr. Srikant Bansod, Head of the Department of Chemistry, Srimati Narsamma College, Amravati, convener of the today international webinar, Dr. Atish Maldure, and co-coordinator of this program, Dr. Mahendra Singh Pawar. Under the dynamic leadership of Sri Sekharji Bondu sir, President Srimati Narsamma Area Shaikshanik Trust, Amravati, Sri Ramji Mahajan, Secretary Srimati Narsamma Area Shaikshanik Trust, Amravati, and honorable management members, our Srimati Narsamma College continuously attain a new heights. Our college offer undergraduate courses in Arts, Commerce and Science College, Science, and postgraduate courses in Organic Chemistry, Industrial Chemistry, Environment Science, Computer Science and Mathematics. We have research center in Chemistry, Botany, Physics, Mathematics and Sociology also. For this international webinar, more than 3,500 participants are registered. I hope participants get benefit from this webinar. Wishing great success to this international webinar. Thank you very much.
Thank you, sir, for your introductory remark. Now, I would like to invite our guest speaker, Honorable Professor Brijesh Pare, sir, President of ACT and Professor Head Department of Chemistry, Madhav Science PG College, Ujjain, to deliver an inaugural address to us. Over to you, sir.
Thank you very much, and very pleasant afternoon and good afternoon to all of you. The first and the foremost, we have a guest today, Professor Sonia from Portugal. So I welcome Professor Sonia for this program. It's an international webinar, and the college from Amravati, that is that Narsamma Arts, Commerce and Science College, in collaboration with Association of Chemistry Teachers, this webinar we are organizing. So all the dignitaries, on the dais, the principal of the college, Dr. Rajesh, Dr. Shrikant, and the convener and the coordinator of the program, and particularly Professor Vasudev Gurnale, probably who is very instrumental in organizing this program along with this college. And what I can see, one of my friend, Dr. Aswar, is also there, who is my colleague in SET. So it's really very pleasant afternoon, and it looks, when even Professor Gurnale is involved in any of the programs, so registration is really goes very platform to so many people and across the border. So I'm very happy to be a part of this program today in an inaugural function. And the title is the Innovation in Science and Technology. This is something very, very relevant, and particularly looking to the new education policy now coming in India from this year onwards. So I hope, we are going to have good deliberations in the coming sessions. And as far as the Association of Chemistry is concerned, I would like to place on record that the Association of Chemistry Teachers has been working in India for the last 20 years. We got established in 20 years back. And since then, we have traveled a substantial distance, and SET has a mandate to popularize chemistry among the young students in India. And we have been doing this through various programs. We are doing one chemistry Olympiad program, for the students. We are doing a very good concept test for the undergraduate students in chemistry. During the pandemic, we have come out with, it's a boon in disguise, with very good programs, even for research also. So we have done one research convention. In that research convention, various speakers from overseas, they joined our program, and we have talked about the various aspects of the research. So that is how, the SET is working, and we are almost, more than 2,500 members of this SET. We have, the faculty from undergraduate colleges, postgraduate colleges, from universities, and from industry and from research institutes. So we have a very good, enthusiastic group of chemistry faculty members. And in India, we are doing many such programs. So I take this opportunity to congratulate the principal of the college, the coordinator, Professor Gurunale, for having organized this program. So I wish you all the best. Thank you very much.
Thank you, sir, for the inaugural remark. I would like to invite Honorable Shri Ramji Mahajan, sir, Secretary of Srimati Narsamma Hiraiya Shaikshanik Trust, Amravati, for the presidential address. Over to you, sir.
Hello, am I audible?
Yes, sir.
Good afternoon, everybody. On behalf of Srimati Narsamma Hiraiya Education Trust, I extend warm welcome to all the respected guests, scholars, participants, and faculty members on the occasion of inaugural function of an international webinar on innovation in science and technology, organized by Department of Chemistry, Srimati Narsamma Arts, Commerce and Science College, Kiran Nagar, Amravati, in association with Association of Chemistry Teachers, Mumbai, to celebrate Silver Jubilee of Srimati Narsamma College, Amravati, and National Science Day. Inaugurator of today's program, Professor Brijesh Pare, President ACT, and Professor and Head of Department of Chemistry, Madhav Science PG College, Ujjain. Speaker of today's program, Professor Sonia AC Carbaneiro, New University of Lisbon, Portugal. Professor Brijesh Pare and Professor Vasudev Gurnule, Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur. Principal of our college, Dr. Rajesh Chandanpat, Dr. Srikant Bansod, Head of Department of Chemistry, Srimati Narsamma College. Convener of today's international webinar, Dr. Atish Maldure, and co-coordinator, Dr. Mahendra Singh Pawar. This trust was founded in 1963 when a great woman, Srimati Narsamma Hiraiya Manyawar, donated 12.5 years ago. Journey in that way started. Journey started with opening of the school. Now we reach. Now we have primary school, junior college, undergraduate course in science, arts and commerce faculty, and several subjects postgraduate courses with all facility research centers. Qualities of altruism, morality, and vision to develop the society into the educated, self-reliant India. Hope this webinar for all participants. I wishing great success to this international. Thank you. Thank you.
Thank you so much, sir. I would like to invite respected Dr. Mahendra Singh Pawar, sir, Department of Chemistry, for the vote of thanks. Over to you, sir.
Good afternoon to all of you. And this is Dr. Mahendra Singh J. Pawar for expressing my gratitude and thankfulness towards the guest of today's function, organized in association with Association of Chemistry Teachers, India, Narsamma College, Srimati Narsamma Arts, Commerce and Science College, Kiran Nagar, Amravati. It is always said that James Allen somewhere, he wrote that, note, hello, am I audible?
Yeah.
Yes, sir.
Hello.
Yes, sir.
Hello, am I audible, sir?
Yes, sir.
Rohini ma'am?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Somewhere it is said that thankfulness is just like a wrapping material and it is not delivered to the person to whom you are giving as a gift. So that thankfulness should be followed with the gratitude also. So I'm here to express my gratitude and thankfulness on the behalf of Srimati Narsamma Hiraiya Shaikshanik Trust, Srimati Narsamma Arts, Commerce and Science College, Kiran Nagar, Amravati, and from Department of Chemistry also. I express my gratitude to Dr. Brijesh Pare, sir, President of Association Chemistry Teachers, Professor and Head Department of Chemistry, Madhav Science PG College, Ujjain. Secondly, I express my gratitude to our trustee, Shri Ramji Mahajan, sir, for giving his precious time, and Dr. Rajesh Chandanpat, sir, Principal of the college. At the same time, I express my gratitude to a very key person, an important person in this whole webinar organization. That is Dr. Vasudev Gurunale sir, Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur. And I'm just avoiding the barrier between you and the speakers, and ending this vote of thanks, and wishing, and I'm confident that this webinar and all the lectures which are formulated in this particular webinar will be definitely helpful for all of us. Thank you. Over to you, ma'am.
Thank you, sir. Once again, I heartily welcome you all. Now we enter in our technical session, international webinar on innovation in science and technology, organized by Department of Chemistry, Srimati Narsamma College, Amravati. On this auspicious occasion, we have a dynamic personality with us as a resource person, Professor Sonia A.C. Carabinero, New University of Lisbon, Portugal. Ma'am had completed graduation in applied chemistry at a New University, Lisbon, Portugal, and obtained her PhD degree in a chemical engineering catalysis in 2001 at the same university. Sir, I'm audible to everyone?
Yes, ma'am. Yes, yes.
Okay, sir. She was postdoctoral researcher from 2001 to 2003 at Leiden University, the Netherlands, and from 2004 to 2007 at the University of Lisbon, Portugal. From 2007 to 2013, she was assistant researcher at the University of Porto, Portugal, and principal researcher from 2013 to 2018. In 2019, she was invited professor in the Wuhan Textile University, China, and integrated researcher at the University of Lisbon. She obtained habilitation in chemistry at the same university. In 2020, she became an assistant professor at the New University of Lisbon. She is a co-author more than 20 chapters in books. More than 160 articles in international scientific journals, more than 200 communications to national, international conferences, and more than 15 invited talks. She is a co-inventor of one worldwide patent, evaluator of several international project proposals. She has more than 4,800 citations and H index of 39 Web of Science. She is a regular referee of several international journals, being currently one of the top female reviewers in the world, Publon Clarivet. She is also a member of editorial and reviewer boards of several journals. Her research interest deals with catalysis by gold nanoparticles, single and mixed metal oxide, nanostructured carbon material, including carbon nanotubes and graphene, heterogenization of homogeneous complexes, and gas-liquid phase oxidation and environmental catalysis. Professor Sonia Ma'am name is included in a list of the top 2% most cited scientists in the world released by Stanford University. Now I request you, Professor Sonia Carabinero Ma'am, to enlighten us with her valuable knowledge on the topic of catalysis by gold. Over to you, ma'am.
Thank you for the nice introduction, and thank you also to the organizers for the invitation. And as it was told, today I'm going to talk about catalysis by gold. And some participants already said that they heard my previous presentation in another conference, and I would like to say that today I'm going to talk about different reactions than those I talked in the previous conference. Before I talked about environmental catalysis by gold, so it was CO oxidation, VOX oxidation, it was CO2 mitigation and nitrogen oxides reduction, and today apart from the initial introduction on gold in general, I'm going to talk about oxidation of alcohols and hydrocarbons. So I think you are already seeing my presentation. I hope you are.
Yes, ma'am.
So let's start. Okay, good. So yes, catalysis by gold. So as it was told, now I come from the new University of Lisbon. So new is nova in Portuguese, means new. So it's new University of Lisbon, and this is the new logo. So it's quite nice. So for you to see a bit where I am located, where Portugal is. So here is the world map. And here is Portugal. So you see, it's a bit far away from India and from other places. So right here at the most western side of Europe. And for you to see the Portugal map here amplified. So here is Lisbon, where I am located now at the new University of Lisbon. And here is Porto, which is the second. And most of the work I did and I'm going to present today was made here at the University of Porto, because before coming to the University of Lisbon, where I am now, I was before almost 10 years in Porto University, also a very good university. But now the new University of Lisbon, here is the campus. This is the campus, and here is the Atlantic Ocean. So it's very, very close to the sea. It's a very, very nice location. So I invite you all to go there once the pandemic is over. So starting the presentation today, I'm going to talk about, just to mention for curiosity, some properties of gold, because gold is a very fascinating metal and I work a lot with it. So as we all know, we have all seen gold jewelry. Well, gold is yellow and shiny. It's the most obvious property of gold. It's also naturally occurring. It appears, it can be found in rivers, streams, etc. Not as much as we would like now, but before, in the old times, people used to go find gold, especially in America. It was very common. And gold also is inert in the bulk state. So if we have a gold bar, we know it will stay like that forever. It doesn't get rusty. It's not like iron, for example. It's also malleable. Malleable means that it can be beaten up to make very thin foils. So the thinnest gold foil that we can make with 1 gram of gold can be up to 3 square meters. So that's quite a lot. It's very malleable. It's also very ductile. Ductile means that you can make very thin wires out of it. So the thinnest wire of gold that you can make is 5 micrometers, which is 10 to 20 times thinner than the thickness of a human hair. So a human hair has about 50 to 100 micrometers diameter. So you can make a gold wire 10 to 20 times thinner than that, which is quite impressive. And also it's very dense, has a very high density for a metal. And the density of gold is 19.3 cubic centimeters per gram, which means that if you have a gold cube of 37 centimeters side, it would weigh a ton. So it's quite remarkable. It also forms alloys, since it's very soft. For us to wear it in jewelry, we have to alloy it, usually with copper or with silver or with other metals, and is also a good conductor of electricity and heat. Well, we have gold nanoparticles in solution. They have different colors. They are not yellow like the gold in the box state. So it's quite interesting, because if we have red, a red solution means we have smaller nanoparticles. They have a narrow absorption band at 520 nanometers and negligible scattering of light for lower sizes. But if we have blue or purple solutions, then we have larger nanoparticles, and the absorption band shifts to longer wavelengths, and light scattering becomes marked for these larger size. So we have here a TEM image of small nanoparticles and another TEM image of larger nanoparticles. And we know that gold is only active in the form of nanoparticles well dispersed on the support, because as I said before, gold is inert in the bulk state. And that's the reason why for so long it was not known that gold could be a good catalyst, because it was inert in the bulk state. So crucial factors affecting activity of gold are the nanoparticle size, which is very important. The smaller, the better, usually. The reducibility of the support, and also the interaction of the support with gold. So here we have an example of gold nanoparticles here, very small gold nanoparticles, 2 to 5 nanometers, on cerium oxide, prepared by a double impregnation method. I will explain later what it is. And we have here a large gold nanoparticle of around 400 nanometers, which is a lot, prepared by incipient wetness impregnation, which is a method that is not suitable for gold because it gives too large gold nanoparticles that are inactive. So that is the problem. And the presence of chlorides, because usually the gold comes in chloride salts, the gold precursor. The presence of chloride causes sinterization of gold nanoparticles, especially at high temperatures, and makes them inactive. So the removal of chloride is very, very important. Well, let's talk a little bit about the gold prices. When catalysis by gold started in the early 2000, the gold price here in June 2005, the gold price was significantly cheaper than most traditional platinum gold, group metals. So here it was 12 euros per gram, which was much cheaper than platinum, much cheaper than rhodium, well, a bit more expensive than palladium. So back then, if somebody asked, oh, gold, isn't it very expensive? We could immediately argue, oh no, gold is about half of the price of platinum, and platinum is a very common catalyst used everywhere. But now, unfortunately, it is not the same. So what happens is that since the 2000 and something, the gold price started to increase, then it decreased a little, stabilized, and now increasing again, and with tendency to go down. I hope it will go down because then my research will be cheaper. And so the current gold price is this, it's 49 euros per gram, which is larger than platinum now. Yes, platinum is 31, but it is lower than palladium. See here, palladium increased a lot from 7 to 61, and rhodium increased even more. Rhodium is extremely expensive. 500, more than 500 euros per gram, it's a lot. So compared to platinum, which is the most common catalyst, gold is a bit more expensive. So we can ask, is there still a golden future for gold catalysts? So I think there is, especially for these reasons. Gold has advantages over other catalysts, which is for CO oxidation, which is the most common reaction studied in gold catalysts. Gold is already active between minus 70 degrees to plus 70 degrees, which means that you can do CO oxidation at room temperature in the North Pole or in very cold areas without needing to heat, while the platinum group metals are only active above 100 to 300 degrees. Also, for the water gas shift, which is similar to CO oxidation but with water, for the production of hydrogen, what happens is that here we see a comparison of gold with copper and platinum catalysts. So we see that gold is already active at 100 degrees C, here already active, while copper and platinum are only start to be active much later on. So to achieve this same conversion, we need a much higher temperature. So this is an important reaction to produce hydrogen for fuel cells. And if we deal with hydrogen generated from a carbon source, like methane, for example, we have these reactions here. So methane and water, it produces hydrogen and CO2. This is not a problem because CO2 doesn't poison the fuel cells. It is okay. However, a little bit of CO is also produced, about 0.5% CO. And you can ask, well, is that a problem, such a little amount of CO? Well, unfortunately it is, because above 0.01%, the platinum proton exchange membrane fuel cells are poisoned by CO. So it's important to remove the CO. It's quite crucial, in fact. And gold, what happens? Gold is very efficient for this CO oxidation reaction, as we saw already. So that's quite good. However, platinum also is quite active. It does the same, although not at the same temperatures, a bit higher temperatures, but okay, it's still active. But the problem of platinum is that it oxidizes everything, not just CO, but also the hydrogen, forming water, which is not good because we want hydrogen. We don't want to convert it back to water. That's the problem. So the advantage of gold is that it's not active for this reaction. It's in fact very selective. It's much more selective than platinum and other platinum group metals for the oxidation of CO in the presence of hydrogen, which is the so-called PROX, or preferential oxidation. So gold prefers to oxidize CO, it doesn't oxidize hydrogen. So that is quite good. And gold also is nearly insensitive to CO2, and its activity is enhanced by water. So gold catalysts are very good candidates for hydrogen production and purification in these needs. And other reactions efficiently catalyzed by gold are this enormous list and much more. So I already said oxidation of CO, the preferential oxidation, water gas shift, oxidation of hydrocarbons, which I will talk a little today, decomposition of volatile organic compounds, oxidation of alcohols, I'll talk a bit today also, selective oxidation of sugars, direct hydrogen peroxide synthesis, selective hydrogenation, ozone decomposition, SO2 removal, NOx reduction, homogeneous catalysis, automotive catalysis, sensors, etc. So very, very much active for many reactions. And so, as I said before, impregnation is not active. It's not good to produce active gold catalysts. So let's see some efficient gold loading methods. So, especially for carbon materials, carbon supports, gold can be loaded by Sol immobilization or a colloidal method, in which the gold precursor is reduced by citric acid, sodium borohydride, or other reducing agents in the presence of an excess of stabilizing agents or surfactants before adding the support. So these surfactants keep the gold nanoparticles apart from each other, and they prevent them from agglomerating, which is a problem, of course. There is the double impregnation method, in which the support is impregnated with the gold precursor and further with another solution of, could be sodium carbonate, and the idea is to remove the chloride. So the sodium chloride is removed by washing. And here we have a good example of gold on zinc oxide prepared by DIM. So you see here very small gold nanoparticles everywhere. And finally, there is the deposition precipitation method, in which the pH of a solution is raised until 9 with sodium hydroxide or urea before addition of the support. And there are other gold metals, but those are the ones I selected today and the ones I will talk about, the ones I used catalysts prepared with these methods for the presentation today. So here is a cover of Chem of this issue of 2017, which was mine and from other colleagues, in which we studied these two reactions. So it was this oxidation of alcohols and also this oxidation of cyclohexane. So this first reaction, the oxidation of alcohols, it's important because these products, which are benzaldehydes coming from the oxidation of benzyl alcohol, and acetophenone coming from the oxidation of methyl benzyl alcohol, are important precursors to pharmaceuticals, to plastic additives. So it's important. And also this reaction, cyclohexane oxidation, to produce cyclohexanone and cyclohexanol, so an alcohol and a ketone, are important reagents for the production of adipic acid and caprolactam that is used in the production of nylon polymers. So nylon polymers are these polymers that can be used to produce clothes, like those winter sweaters, for example, and also these nylon pantyhose for women. And the problem of the present industrial process used to for the cyclohexane oxidation, the problem of the present industrial process is that it uses a homogeneous CO, cobalt catalyst, uses oxygen, and is 150 degrees temperature, and the yields are very slow, from 4 to 12% yields, and the selectivity is also only 80 to 85%. So it is important to find other methods for this reaction, greener methods than this that don't need such a high temperature. And so we have here some results of the oxidation of cyclohexanol to produce cyclohexane to produce cyclohexanol and cyclohexanol. So we have here results of gold catalysts on several supports. So here on carbon nanotubes, on activated carbon, on nanodiamonds, this is nanodiamonds in powder and nanodiamonds in liquid, on microdiamonds, and on carbon aerogels that are polymeric carbon materials. So we have the results here, and we see that the best results were obtained with carbon nanotubes, and the yield was 3.6%, which is similar to the industrial process that was 4%, but obtained in milder conditions, which was room temperature and 6 hours. Remember that the industrial process needed 150 degrees. And here it was room temperature, and just 6 hours we obtained a yield very similar, shall we say. So here we have some TEM images of these catalysts, the nanotubes, prepared by both methods. So this is the colloidal metal and the double impregnation method that I talked before. So the colloidal metal was more effective in all catalysts. So better tones were obtained. And if we look here at the gold sizes, we see that it was supposed that the best catalysts would be the aerogels, if only the size of gold nanoparticles would matter. But no, we see that carbon nanotubes are in fact the best method, and the aerogels, although they have a very small nanoparticle size, they were not active at all. So what we realized was that the activity was not only related with the gold side, but also with the mesoporosity of the supports, which seemed to have a detrimental effect, both for the aerogels and also for the nanodiamonds, which were also not so active. So we did a recycling test here of the best catalyst is here. And we see that up to 6 cycles, there is a very little decrease in the activity. There is no leaching of gold. So it was a quite good result. Also, we have some gold catalysts here prepared by deposition precipitation. So on aluminum, on titania, on iron oxide, and on zinc oxide. So we see here the sizes obtained. So the smallest are here, titanium. And we had here gold 0, here gold 1. So depends on the support, the size of the nanoparticles and also the oxidation state prepared by the same method. So here we have results of cyclohexane oxidation to cyclohexanol and cyclohexanone. And we have here 2 types of oxidants. So we have H2O2, which is the greenest of all, the greenest peroxide that is not so green, but not so bad. There are worse oxidants. And then we saw that there was a very high selectivity for Ka oil, which is the ketone alcohol oil, is cyclohexanol and cyclohexanone, with no traces of byproducts. And in fact, we saw something interesting was that a very high selectivity here for the alcohol, because usually a mixture of both is obtained. But here with this catalyst, we obtained a very rare selectivity to alcohol. And here, especially here at 4 hours reaction with this greener oxidant, we obtained the best yield and this interesting selectivity. So this gold on iron oxide achieves more yield and faster in this oxidant, which is the greenest of all. And the activity order you see here is related with reducibility of the support, because this is a very reducible support and others are not. And this implies also a correlation between the reducibility of the support and the surface oxygen bonding to the catalytic activity. And these tests, they were carried out at 60 degrees Celsius, atmospheric pressure, and with low loads of catalysts, and without the need of acid, because the industrial process needs very high temperature, 150, and high loads of a cobalt catalyst. So as you see, and we obtain here 13% yield, which is above the industrial process. And also here, if we look at the cyclohexanol with reaction time, for several reaction times, we see here, like I was saying, this very high and very rare selectivity at 4 hours for almost exclusive formation of cyclohexanol, which is very rare because usually it's a mixture of both cyclohexanol and cyclohexanol that is obtained. And if we do several cycles to recycle the catalyst, up to 3 cycles, there is not much difference in activity, but or in catalyst leaching, up to here the 3 cycles. But then as we continue here at 5 cycles, the activity decreases a lot. And we realized by thermogravimetric analysis that there was some adsorbed organic compounds, so coke precursors, that might lead to the deactivation of the catalyst. So this was the problem. So this was gold on iron oxide. And now some results for the oxidation of alcohols. So microwave assisted solvent and additive free oxidation of alcohols. So we use no additives and no solvents, just the alcohol with the catalyst and the oxidant. So you obtain these results here for the benzyl alcohol oxidation and for the methyl benzyl alcohol oxidation. So the best ones here were iron oxide, gold on iron oxide, and here gold on titanium dioxide. So we can see that very high selectivities were obtained, see, above 99% for both benzyl diide here and here for acetophenol, with no traces of byproducts. So very high selectivities. And the best results, like I said, were obtained for gold on iron oxide for this benzyl alcohol oxidation, and for gold on titanium dioxide for methyl benzyl alcohol oxidation. Again, solvent-free conditions in the absence of any additive. So it was 1 hour reaction in microwave irradiation at 100 degrees. So it was, and we had to use the terbutyl hydroperoxide because H2O2 decomposes in these conditions. So here, the results for the oxidation of methyl benzyl alcohol. We see here the supports and the supports with gold. So we see here that iron oxide is the most active support. So again, it must be related with reducibility because it's very reducible. However, we see that the largest increase upon gold loading is here for titanium dioxide. That goes from 5% yield to 91% yield just with 1% gold being added to the catalyst. See? So this large increase compared to the other catalysts is possibly related with the lowest gold size obtained on titanium, which is quite interesting. And the top values obtained for these gold on these catalysts are much higher than those reported in literature. So it shows the advantages of microwave irradiation. So we did some recycling tests of gold on titanium dioxide, and we see here up to 10 cycles, and we see here that up to here is fine. Here at the 5th cycle, we start to have a small leaching, and then here at the 10th cycle, we have already 90% leaching, and the gold size from 2.2 to 6.5 nanometers. So that is the problem. And here we have some gold catalysts prepared by deposition precipitation with urea with different amounts of gold. So we have 0.5% and 4%, and different pretreatments, hydrogen or oxygen pretreatment. So here we have on titanium dioxide. Here we have on cerium titanium, so it's mixed support. Here we have lanthanum titania, so 0.5. All this is on hydrogen, this is on oxygen. And here exactly the same, but with 4%. So the same supports, mixed supports, and different treatments. So we have different sizes of gold nanoparticles and also different size distributions, but usually small size in all the cases. So we have the oxidation of methyl benzyl alcohol using this gold on mixed oxide catalyst. So this is the reaction. It was performed at 80 degrees using an oxidant of terbutyl hydroperoxide. Sorry. So we have here the best result obtained was with this with 4% gold on lanthanum titanium support pretreated in hydrogen, and we obtained a 98% yield of acetophenol. So here is the best catalyst. And if we do a recycle, we see here that the activity decreases a little, but the reaction was performed in mild conditions, 80 degrees and 1 hour. So also without acids, alkali, without microwave or solvent. So it's just a reaction, a very plain simple. Although this decrease in the yield, the selectivity was always maintained. And here we have, it was a front cover of a ChemCat-Chem journal and a cover profile. So it was a joint work between the University of Porto, where I was back then, and some universities of Mexico, and of Spain and of Russia. So here all the participants, it was dealing with octanol oxidation, so green oxidation of octanol, that it was made with nano gold catalysts. So here we have the octanol oxidation, the route that it can follow. And here we have the results. So it was performed at 1 atmosphere, room atmospheric pressure and 80 degrees Celsius. And we see that the best result here was 0.5% gold on platinum titanium catalysts pretreated in oxygen. So it was a 62 conversion at 6 hours and 62 selectivity to ester. And this catalyst has the highest surface concentration of gold plus ions, so gold 1, and the lowest gold nanoparticle size that gave these results. So we see here the XPS. So by XPS, we know if we have gold 0 or gold 1 or gold 3, of course. So we see here that this one had gold, the largest amount of gold 1 compared to the others, of course, also had gold 0 and a mixture. So those were the results that were reported here. So we also did oxidation of betulin. So betulin is comes from the birch tree, betula, which is called betula in Latin. And betulin is this terpene, so from the lupin series, and gives all these derivatives. And the betulin oxoderivatives, they have anti-tumor, anti-inflammatory, anti-parasitic, anti-HIV activities, and they are of interest for the pharmaceutical, cosmetic, and food industry. So it's important to study them. So the oxoderivatives can be synthesized by oxidation, and if that is done, we have chromium toxic compounds are used as oxidants. A strongly acidic medium, low yields are obtained, low selectivity from -5 to 10 degrees. So this can only be done in Russia. That explains why the Russians are involved in this work. Very long reaction times, complex purification procedures, several organic solvents and methods. So not good, not good. And also biological transformation can be used, but also then other disadvantages. Opportunist yeasts and fungi, complex nutrient media, long duration, low amounts of starting compound, low tolerance of the biocatalyst, and low conversion. So we used an unprecedented greener reaction that was published recently in Green Chemistry journal. And we see here, at relatively mild conditions, 140 degrees Celsius, synthetic air as the oxidant. And the best result was with this catalyst, this mixed catalyst. And we obtained the betulin conversion of 69 and this selectivity to these main products. So it was a good result. Also, I have been doing heterogenization of catalysts. So we have here the homogeneous catalysts. They have high activity and anti-selectivity and non-catalyzed structures. So we have complex here dissolved in the media. So it's homogeneous, everything in the same in the liquid state, shall we say. We can have heterogeneous catalysis, which is the catalyst is in a solid form compared with liquid or gas phase. And then we have easier separation from the reaction products just by filtration, possibility of recycle, and can be applied to continuous flow processes. And if we heterogenize the homogeneous complexes, if we link them to heterogeneous supports, we can have better advantages because we can recycle them, minimize workout procedures, reduce costs, decrease toxic wastes, and have the best advantages of both worlds, shall we say. So we used carbon materials as support, activated carbon, carbon sherogel, carbon nanotubes, and the materials were functionalized. For example, for carbon nanotubes, it was a reflux with acid, and then we obtained carbon nanotubes acid functionalized, and then if we functionalize those with sodium hydroxide, we obtain these carboxylate salts. And so we anchored on the carbon catalysts, on the carbon supports, scorpionate metal complexes. They are called scorpionates because they coordinate to the metal like a scorpion attack. So, and then those are this is the formula of the gold complexes. They are heterogenized by stirring in methanol from 2 to 8 hours at room temperature. It's enough. And it's a very fast process because here you see before and after 1 hour, the complex already disappeared from solution. It's already anchored on the carbon support. And this was the first report of heterogenization of gold complexes on carbon supports. It was reported by us in 2013. It was before never a gold complex had been heterogenized on carbon supports. And so we did the oxidation of cyclohexane, the same reaction, and here room temperature 6 hours. So we see here that the heterogenization produces better results because here is homogeneous, just the complex itself. This is one of the complexes, and here heterogenized on several carbon supports, the tones were better. So carbon nanotubes gave the best results here, carbon nanotubes, and this ox-Na treatment is the treatment with acid and then sodium hydroxide is the best results because this one here, and this one here are usually the best. High selectivities, no trace of byproducts, no need for acid. In fact, acid was an inhibitor, and less amount of oxidant needed, and the results were much better than the obtained with the gold nanoparticles on the same carbon supports on oxides, which was quite good. So the yield was 16%. Remember that this was only 4%, and higher temperatures, higher amounts of catalyst, etc. And here we did a recycling of the catalyst, and well, some activity lost, but still it could be recycled. And the homogeneous complex, no, it's only once and then it goes to the trash. So here we did also heterogenization of commercial gold complexes. So it was another front cover of ChemCat-Chem journal with cover profile. So it was again the University of Porto with, it was me and another professor and 2 other professors from the University of Lisbon. And these were the gold complexes that gold 1 and gold 3 complexes. And this was the first report of such complexes used in the oxidation of carbon hydrogen bonds. So we have here the same reactions. It was the alkyl and the cyclohexane oxidation. So here, some results, some example of results with this, the heterogenization of this complex on the carbon nanotubes. So we see here again homogeneous, and if we heterogenize, we obtain better results. So heterogenization is better. Again, carbon nanotubes give the best results, especially with this oxidation treatment with further sodium hydroxide, and again high selectivities with no trace of byproducts. And the best result was this complex with a 26% yield, which was better than the 16% of heterogenized scorpionates I showed before. But here we had to use acid and terbutyl hydroperoxide, while the scorpionates did not need acid, and H2O2 was used instead. So We obtain better yield, but we have harsher conditions. So we have to choose what we prefer. And see here a good recycling was obtained and a similar level of activity, only small leaching was found. For methyl benzyl alcohol oxidation, just a comparison, we have here another complex heterogenized. Again, better results for the heterogenized catalyst. This is the homogeneous complex, so just this part. This is heterogenized on different carbon supports. Again, carbon nanotubes give the best results, and also this oxy-Na treatment is the best. And we obtained 90% yield, that was slightly lower than gold on oxide supports. And still good recycling was obtained, see, up to 10 cycles, with only a small decrease here in the 8th cycle, and then just due to a small leaching only up to this cycle. So it's quite good that we heterogenize, because complexes can be reused again, and if it was homogeneous, no. So finally, some conclusions. Gold nanoparticles, they are good catalysts for several types of reaction. They occur at much lower temperatures than without a catalyst, and the small size of gold is very important, but it's not able to explain everything. Sometimes the activity depends also on the nature of the support, on the gold oxidation state and the interaction of the support with gold. Heterogenized gold complexes, they have advantages over homogeneous analogs due to the high activities and possibility of recycling. And in some cases, higher yields are obtained in greener and milder conditions compared to gold nanoparticles on similar supports. So my final conclusion is that gold catalysts have a golden future, indeed. So some acknowledgements for funding, for collaborations, etc. And I invite you all to visit Portugal once the pandemic is over, especially Lisbon, where I am now, that has these very nice locations for you to see. So thank you for your attention.
Thank you so much, ma'am, for your valuable guidance. If anyone has any question, please write it on a chat box. I'm sure would be pleased to answer them. Now proceeding further, our next speaker for today's technical session.
Hello, Rohini.
Respected
Rohini,
Professor
1 minute.
Brijesh Pare, sir.
Hello, Rohini.
Hello, sir. Yes, sir.
Madam, one question is
I'm
asking
audible, sir.
one professor. Are there particle size depends on the catalytic efficiency? Are there particle size dependence on the catalytic efficiency?
Oh, yes. 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 Yes, because we saw that in some cases there before, we saw that the best results were obtained with lower sizes. For example, here, this one, the best result was with the lowest gold nanoparticle size. But, well, today I'm only talking about this type of reactions, but I also studied other reactions like CO oxidation, and in fact, we found that indeed the best size is smaller, the smaller sizes. However, the small size is sometimes not enough to explain everything, because you see here, for example, in this reaction here, the smallest size was with Sherogel, and it was not the best result. So size is important, but also the support nature, the interaction of the support with gold, etc.
Okay, thank you. Another question is there from Professor Peter from Nigeria. What are the effects of shapes on the gold nanoparticle activity?
Okay, I did not study effects of shape, because all particles are obtained are usually they have usually round sizes, spherical sizes.
Okay.
See, let's, I'll show you here some. Here, see, the sizes are usually spherical. So I did not study those effects. There are sometimes you can obtain rods, nanorods, you can obtain nano triangles, etc. But here, with these methods, we only obtain the round sizes, so spherical sizes. So that I do not,
Okay, thank
I
you,
cannot
madam.
talk
Okay.
about.
Hello, any question from audience?
If any question, please ask. Sir,
Okay, madam. Nice
can
presentation.
we proceed?
Yeah.
Now proceed.
Yeah.
Now proceeding further, our next speaker for today's technical session, respected Professor Brijesh Paresar, President of Association of Chemistry Teacher and Professor Head Department of Chemistry, Madhav Science PG College, Ujjain. Sir has completed MSc, MPhil, PhD and postdoctorate fellowship. Currently, Sir is working as a professor and head, also has postdoctoral research fellowship for National Research Foundation, Pretoria from May 99, May 2000, work in the Department of Chemistry, University of Durban, Westville. Sir had published more than 70 research papers in various information and national journal of repute. And INSA nominated affiliate membership of IUPAC UNESCO 2013 to 12 to 13. Organized more than 100 chemistry popularization workshops for students and teachers across India, Abu Dhabi, Dubai, Sharjah, Doha, UAE, and Qatar.
Thank you. Thank you
Sir,
for
working
the.
actively with the Royal. Okay, sir. I invite Professor Brijesh Paresar to give a brief idea on the topic of can we learn to be innovative? Over to you, sir.
Okay, thank you very much. Thank you for the nice introduction. And really listening to Professor Sonia was very mesmerizing and a wonderful piece of work she has presented. And really, I enjoyed listening to that. So I once again thank you to the organizers for having given this opportunity to speak. And Professor Vasudev Gurunale, who is very instrumental in organizing this program with the Amaravati College, and he will be the next speaker, So he's a very active person. Anyway, thank you very much once again. So today what I'm going to talk is something slightly different from the usual talks. And I thought, because in Indian context, from this year, we are going to have a new education policy. And in the new education policy, the stress is quite much given on the creative and the critical thinking and the creativity, innovation at various level, at undergraduate level, at postgraduate level, and all that. Because let me tell you, this is something very important. Recently, the world is divided into two parts: those who do innovation and those who do not do innovations. As just you can see globally, I mean, those who are quite advanced countries, they are very much into innovation. But anyway, those who are lagging behind, probably they may not be that good at innovation. And that is what, anyway, it's a different discussion, But you can just very well see the economical might of the countries, mostly depends on innovation and creativity in the field of science and technology. So what we are going to deliberate, and what I'm going to just to discuss few things, that what are those things, which can be inculcated just by utilizing those methods, we can inculcate interest and creativity among the young students. So let us see, what the creativity is, so creativity is an endless renewable source, just like an energy, So, and we can tap into it at any time. as children, let us just going down the memory lane, when we were young, and as children we naturally draw our imagination, and curiosity, in an attempt to make sense of so many complicated world around us. Just we try to understand, we try to make sense of the things, we try to understand the things and the phenomena. We experiment with everything in our around us, dropping things to see, how far they fall, just banging things together and to see how they sound, and touching all the things, we can get our hands on to see how they feel. So the sound and the vision and the feeling, so many experimentation, as a children we used to do. So it looks, like the human, as a just by both, inborn capacity to imagine the things, that is something very natural. Then but what goes later on, that also we need to see. Now see, we mix together the random ingredients, during our, when we are a child, in the kitchen, we just mix many things and try to see, how they taste, we make various new games, with our friends and imagine, what it would like to live on the other planets. So lot of imagination. We try to stretch our imagination to the extent, that sometimes we just plan to go to the other planets, and how it would look to go to their island. So essentially, we have both the creative competence and confidence. And the adults around us encourage our creative endeavors, building environment that tickle our imagination, very supportive environment as a children we get, and our imagination has no borders, we can think we can go to any extent. Then what happens, where the fault lies sometimes, like during the adulthood, as we approach the adulthood, we are expected to be very serious, to work hard, and to be very productive. That is the first thing. You have to produce something. There is an ever increasing emphasis on planning and preparing for the future rather than experimenting and exploring in the present. And the spaces in which we work reflect this new focus. Where we are working, everywhere, people, they want, to produce and to produce and to give, nobody, gives you time and energy and space, where, you can just we have a kind of ingenuity, inventiveness. So with this type of external pressure and messaging, we shut down our natural curiosity and creativity as we strive to deliver what is expected of us. So we are more into now producing, we are more, we are not into creating something, something new. And with that, the imagination gets really hampered severely. Okay, I will just let you know a few things. There is, like one word exam. In Oxford University, in one of the colleges, they used to have one very popular exam that is known as the one-word exam. And what they do in that exam, these two, it's a kind of entrance examination for that reputed college of Oxford. So they allow all the participants to just take out one piece of paper, where only one word is given, and that word, it may be provocative, it may be water, it may be exemplary, it may be torture, something. Just one word is given to the entrant, that student, and 3 hours are given. 3 hours are given to stretch the imagination. They're allowed to write whatever they like for the 3 hours. It's a kind of an essay examination. It is so popular that even, when the results come out, many people, those who have not entered, appeared in the examination, they come to see the result, because see, and moreover, such exams, tests, they do not have a fixed answer. There is no fixed answer for that. But as a participant, you get enormous opportunity to stretch your imagination to any extent possible. And the result of that competition, that is the one-word competition, is so exciting, and it gives what a wonderful opportunity to the participants to be more and more creative and just to explore, their inner side, their mind, and they do really marvelous. So for many of us, I'm also there, this type of creativity hasn't been fostered, no, I mean, sometimes, you are not encouraged to do that, you're not, I mean, we don't have the very encouraging society, to push you forward for that. So we don't, so we don't look at everything in our environment as an opportunity for, yeah. So that, that is what we start missing, we don't look things around in our environment for ingenuity because of that. So this popular essay test, that is one of the things, where you can use as a tool, as a method of allowing the students to stretch their imagination. I mean, this is one of the things can be done, yeah. To be very creative, one has to be basically a keen observant of the surroundings, the immediate environment, what's going on, what's the sound, what is happening around you, and all kinds of things. And once you are observant, that really, and you get some data, you get some knowledge from your environment, and that makes you more imaginative. And once you are imaginative and you have the ability, to be very creatively connecting those dots, so that leads to the innovation. And once you are innovative as a society, I mean, really, you do much better. And that is something, that thrives the whole life, that keeps your life going. You don't get bored of the things. So creative problem solving is not considered a skill to be learned. From the teaching point of view, from the faculty point of view, I mean, we need to look into it, that how many classes we have taken, or suppose we are teaching something at any level, if you are teaching, I mean, at secondary level or undergraduate level or a postgraduate level, where you have ever tried to create, to inculcate among your students the creative problem solving abilities. That is because that is one of the I should say, the duties of a teacher, as a faculty. So just look around, and it becomes clear that the innovators among us are the ones succeeding in every arena, from science and technology to education and to the arts. If suppose you have that ability, you have that I mean, keen observant, you are a good imaginator, definitely then you are having a better creativity that leads to the innovation, and then really you excel in all the fields. And nevertheless, creative problem solving is rarely taught in school, colleges, universities, or even considered as a skill to be learned or can be taught. This is where I wish to discuss whether it is possible to teach, or whether it is possible to learn creativity, or it is something very innate. Okay, so there is a good, see, the brains. Now let us think about the brain. So the brains are built for creative problem solving. That is a good news, and it's a great news that our brains are built for creative problem solving. Okay, I mean, some difficult problems, whenever comes, so our brain takes it as a challenge, and it can solve the problem, any problem. And it is easy to both uncover and enhance our natural inventiveness. It's a very good news. I mean, whatever you have, that can be uncovered, and even you can go beyond that. I mean, whatever naturally ability you have for it, you can go beyond that. I mean, it can be enhanced. The human brain evolved over millions of years from a small collection of nerve cells with limited functionality to a now fabulously complex organ that is optimized for innovation. So this is something good. I mean, every human being has this capability to go for innovation, and that is a natural capability of the brain. That we have the ability to come up with an endless set of novel responses to the world around us is a constant reminder that we are born to be inventive. See, a very small thing, like, every day in our life, if suppose you are writing a mail to somebody, you are responding a question to somebody, you are doing any household thing, you are working in your laboratory, you are teaching something, you are reading, every time our mind constantly responding to the new challenges. They may be small, even in, suppose you are working in a kitchen, somebody, and one particular, thing is not available, which you want to put into the any kind of a spice, it is not missing. What would you do? You try to find out an alternative of that. So mind is working on it. If you are not getting one particular thing which you wanted to have, but it is missing, and the mind starts working on something else. And certainly, most of the times, you get a sometimes you get a better alternative of the thing what you are looking for. So that is, a kind of an indication that mind is really innate for it, and it is, I would say, the hardwired, to help you to go for innovation. Creativity can be taught and learned. That is a good thing. Many people question whether creativity can be taught and learned. They believe that creative abilities are fixed, just like the color of your eyes that cannot be changed. And there is a concrete, they feel as if there are people, those who have the natural and innate ability to be creative, to be innovative. So that is not the thing. That is not the thing. And how is that is very natural to everyone. Each and everyone has a potential to do that. So there is a concrete set of methods and environmental factors that can be used to enhance imagination. And by optimizing these variables, creativity naturally increases. So that is a wonderful news. That everybody can stretch forward, the imagination. Thereby, he would be more innovative. But why it is not happening, Unfortunately, these tools are rarely presented in a formalized way. And as a result, the creativity appears to most people to be something magical, rather than natural result of a clear set of processes and conditions. So that is what we need to really make very clear, that innovation is, not only for the few placed people or some very special people, but anybody can do it. But the onus sometimes is on the instructor, or I would say as a faculty, as a teacher on us, that it can be that kind of this skill can be imparted to our student at any stage, no matter it is undergraduate, postgraduate, or maybe a research level. It can be imparted, but the onus is on us as a faculty member, as a professor, as a teacher. I would like to mention the name of Professor Tina Selig. She is a very senior professor of Stanford University, and she's working for the last so many years on the courses of creativity. And with that, she has come out with something very, very concrete, and she has nicely theorized the whole process, and she has designed, and just put forward one innovation engine. Just you can see this, this is given by Tina Selig. So this is an engine, where there are 6, I would call the parameters for innovation kind of thing, to have the ability to be innovative. So it starts from, it's like this is the inner side, of that. This is the inner side where it is written knowledge, imagination, and attitude. This is the inside edge. But it is followed by 3 other things, that is resources, habitat, and culture. I will just let you know how these 3 are going to affect. Now, the inside of the innovation engine, there are 3 parts. The first one was the knowledge, which provides the fuel to your imagination. So to be imaginative, you need to have the knowledge. That is the first. Your imagination is the catalyst for the transformation of knowledge into ideas. So once you have a good knowledge, it leads to imagination. Once you are imaginative, so that imagination is a catalyst for the transformation of your knowledge into the ideas. Then third is the attitude. That is very important. Your attitude is a spark to set the innovation engine in motion. As we know that, for any engine to set in motion, you have to have a spark. So attitude is very important. The attitude, that means, yes, I can do it. Yes, I can do it. And you should have that much of confidence, and then you can do it. So these are the 3 things, okay? Knowledge, imagination, and what is the third? Attitude. Fine. Now, but there are outside influences also. for a society or for an individual to be innovative. Resources are all the assets in your community, the community in which you are residing, you are living, all the resources, you are going to use those resources, Then habitats are your local environment, your home, your school, your office, your college, and everything. That is habitats. And the culture is a collective belief, the values and the behaviors. Like, the culture has to be very, very encouraging for an individual or for a society to be innovative. If suppose, what happens, as in a school or in a college or in the university, if a student, comes out with something very awkward, and very absurd kind of results, for one particular problem, and if he is reprimanded or he is scolded, immediately, so he's not going to be encouraged with that. But if suppose the culture, if your society is like that, who supports any kind of innovation, any kind of creativity, because, most of the creative works and innovations initially looks very absurd. I mean, sometimes, they may be absurd, but many times all the big inventions, and discoveries, they look very absurd. But it is for the seniors, it is for the society, the others, those who are there around that fellow, the innovator, to be very, very encouraging and very supportive. So if you have a culture like that, so I think these are the three parts of the outside part of the innovation engine. That is resources. You have more resources, you can utilize it, or just you can generate more resources. And habitat, that is very important. So this is very happy with this innovation engine. And just by working on these kind of things, we can have a better, more innovative society, and we can work more for the science and technology. Acute observation is the key skill for gaining valuable knowledge. Yeah, because we are talking about the knowledge. The knowledge comes with the observation, and this knowledge is the fuel for imagination. Just we have talked. Let us see. I just want to talk this example. I have taken from Dr. Tina Slick's one research paper, and it shows how to deal with our students, and how to inculcate innovation in that. So what they have done, they have given a very small, a very simple exercise to the students, so the instructor, said the redesigning of the name tag, the tag, which is put, when you go to any conference or anywhere in the office somewhere, so you put your name tag, So it was told to the students that we don't like name tags at all. The instructor said, okay, the text is too small to read. They don't include the information the instructor wants to know, and they are often hanging around the wearer's belt buckle, which is really awkward. The students laugh when they realize that they too have been frustrated by the same problem. So this was a small, see how the element of the innovation, how the element of creativity comes into play, how it can be sparked. So this was such a simple exercise given to the group of students. Now see the reaction, what happened. Within 15 minutes, the class has replaced the name tags hanging around their necks with beautifully decorated piece of paper with their names in large text. See, the instructor, initially said that the names are in small, the text was small, so they made large text. And the new name tags were pinned neatly to their shirts. They've done it. They are pleased. They have successfully solved the problem and are ready to go on to the next one. But the instructor had something else in mind. He collected all the new name tags and put them in the shredder. The students were surprised and really they thought, what has happened to the instructor? He collected all the things and just almost throw away. Instructor asked them, why do you use name tags at all? Now the next question. At first, the students think that this is a kind of a preposterous question. Isn't the answer obvious? See, they thought, everybody knows, that why do you use the name tag? Of course, we use name tag so that others can see our name. That was the answer. They quickly realized, however, that they have never thought about this question. But I mean, they might have, just stayed for a few seconds. They replied to it, but they also thought that for the first time they realized, they thought about it, why they are using the name tags. After a short discussion, the students acknowledged that the name tags serve a sophisticated set of functions, including stimulating conversation between people who do not know each other, helping to avoid the embarrassment of forgetting someone's name. I mean, those, going very frequently to the conferences like Professor Gurunale, those who are visiting and meeting so many new people in the conference, so we all come across these kind of thing, so forgetting someone's name and allowing you to quickly learn about the person with whom you are talking. Sometimes this happens and it really just put you into a very awkward situation. So that is what, this kind of, things were going in their mind. With this expanded appreciation of the role of name tag, students interview one another to learn how they want to engage with new people and how they want others to engage with them. Because see, where the name tag was supporting a kind of a conversation between two slightly new persons, in a conference somewhere. These interviews provide fresh insight that lead them to create an inventive new solution to push beyond the limitations of a traditional norm. Here the creativity has come into play. One team broke free from the size constraint. What happened initially, it was a small tag, they made it a large, that was the size constraint of the tiny tag, and designed a custom t-shirt. Now they just threw away that, small piece of paper or a piece of the plastic kind of thing, and designed a custom t-shirt with a mix of information about the wearer in both words and pictures. Features were the places they had lived, the sports they played, their favorite music, the members of their family. They vastly expanded the concept of the name tag. I mean, it was not a name tag at all. It was. I mean, a kind of a short resume, I would say. Instead of wearing a tiny tag on their shirts, each shirt literally became a name tag, offering lots of topics to explore. Another team realized that when you meet someone new, it would be helpful to have relevant information about that person fed to you on an as needed basis to help keep the conversation going and to avoid embracing silences. They mocked up an earpiece that whispers information about the person with whom you are talking. See, from where that, from the small tag, they have developed an earpiece. It discreetly reveals helpful facts such as how to pronounce the person's name, his or her place of employment, and the names of mutual friends. I mean, see how things got extended now. Yet another team realized that in order to facilitate meaningful connection between people, it is often more important to know how the other person is feeling than it is to know a collection of facts about them. Okay. Now they went a step ahead. Instead of giving so many related information related to the person to whom you are talking, the feeling has come into the play. Feeling. They designed a set of colored the bracelet, each of which denotes a different mood. The green ribbon means you feel cheerful, the red ribbon, you feel stressed, the purple ribbon, the fortunate and all that. Just by combining the different color ribbons, a wide range of emotions can be quickly communicated to others. See the level of innovation, facilitating a more meaningful first connection. That was the purpose of the tag, So see how the groups within a larger group, they were working on it. So this is how, the ingenuity, the inventiveness, has to be inculcated. It is to be possible and it can be done. Okay. Are you paying attention? So I'm giving one small story about that. So if you have to be very creative, you have to be innovative, you have to be, definitely we talked about it, the observation has to be acute, and you should have a focused observation in order to identify opportunities for innovation. That is very important. And just a very, very small story I'm giving you, a wonderful story by an American novelist, David Foster Wallace. This story he designed, like to say, what is observation. So two young fish swim past an older fish. As they pass the older fish, he says, "Morning, boys. How is the water?" See, they are somewhere in the sea, or maybe in river, everywhere around water. But what the older fish ask, "Morning, boys. How is the water?" The two young fish continue on for a while until one eventually asks the other, "What the hell is water?" So that is the thing, They are into water all through their lives. The fish, they take birth and die there only, but they are not aware of their immediate surrounding. So that is a very powerful thing, to you just bring your attention about the message in this fable is that we often don't notice the things that are most important to our lives. We are literally blind to the water. So that is what is required. One has to be creative. Acute observation is a key skill again, and this knowledge is the fuel. This knowledge is the fuel for your imagination. Okay, one small thing like from Steve Blank, is a very serial entrepreneur. He provides a great example. He has been on the founding team of some 8 to 10 different companies. So many people have the praise Steve for his creativity and fearlessness. He says that I'm not brave, I'm just incredibly observant. So one has to be incredibly observant. Steve has discovered that the more you observe, the more data you collect, and the more patterns you see, and the more boldly you can act. That is the key to be the innovative. Okay. So as Steve would say, this is the big idea. This is the big idea. I mean, just you have a good observation, get more data, collect more data, have more patterns out of the data, and then more boldly you can act. Okay. So I think I should, this is sufficient for my today's thing. And thank you very much. Today I wanted to speak on a slightly different mode, and this is how I think for my students particularly, how can be very creative. Thank you very much. Thank you organizers for giving me this opportunity.
Thank you, sir, for guiding us. Now moving toward last speaker of our technical session, respected Dr. Vasudev B. Gurnule sir, Professor Department of Chemistry, West Zone, Kamla Nehru Mahavidyalay, Shakardara, Nagpur. Sir is presently working as a professor in Department of Chemistry, Kamla Nehru Mahavidyalay, Nagpur. Sir is recently honored by 2018 Albert Nelson Marcus Lifetime Achievement Award and Best Researcher Award by Rashtrasant Tukdoji Maharaj, Nagpur University, Nagpur. Sir has delivered more than 35 talks in national international conferences, organized 6 national and 3 international conferences for the researcher of India and abroad. Now I invite respected Dr. Vasudev Gurnule sir to throw light on the topic SBR, antimony oxide rubber nanocomposite. Over to you, sir. Hello, sir. Hello, sir. Can
Okay.
I?
Hello. Yes. Okay. I'm sharing the screen. Okay.
Okay, sir. Thank you.
Hello, sir.
Rohini, is screen visible?
Yes, sir. Yes, sir.
So first of all, I thanks for your brief introduction, and also I thanks the organizer for giving me an opportunity to present my research work here. So today I'm going to discuss the SBR antimony oxide rubber nanocomposite materials. As we know, there are different types of polymers and different composite materials are there. So we are going to discuss all these different aspects about the polymeric and rubber matrix material. So as we know, in our everyday life, we find number of things, and here we use the polymeric material for the different purposes. And here it is shown in this slide that we can use this material as a textile and as a adhesive material in paint industry, or as a electronic material for packaging material, and also for the automobile and healthcare. But now here we are interested to study for the what is the use of this rubber, particularly for the rubber industry. And so here for the automobile, rubber is a very important material. So number of uses are there, but out of that we are going to discuss the rubber material in this part. Now, when we are going to discuss the advanced polymers, in that case, what is now advanced polymer is nothing but the smart polymers, and the smart polymers have also number of applications in the research field and also in different field. We can use these smart polymers as artificial muscles in a sensor. So these are the we can also use some polymeric material for the separation and for the purification. Also, there are some fibers which are showing shape changing activities are there, viscosity modifier, or also in sense controlling the release of the shape and materials. So different advanced or smart polymers are there. We can use this material for different purpose. And now by the introduction of some nanofillers in the polymer, and then we enhance the properties or the activities of the material. And we have tried number of nanofillers to increase the or to enhance the properties of the polymeric material. And now here, as we know that high surface to volume ratio increases, there is a high crystallinity, high mechanical strength. In case increase the chemical resistivity, increase the sketching resistance. And now, as we know, introduction of this nanofiller in the polymer matrix, then it show the degree of dispersion. They show the changes in the size, shape, orientation in the nanoscale, and there is a interaction between the second phase of polymeric and matrix and the fillers are there. So these interactions, how they are taking place, how they enhance the properties, that we are going to see here by the introduction of nanomaterials or nanofillers in the polymer matrix. Whenever we are discussing the polymer nanocomposite materials, as we know, there are high performance polymers include plastic, fluids, membrane, smart hydrogels, and elastomers that are designed to meet the requirement that engineers face every day. And now we can say that there are so many materials, they show multifunctionality, and they changes the properties, like they are transparent, flexible, electrical conducting polymers, increase the environmental stability, increase the diffusion constant, increase the durability, thermal stability also get enhanced, biodegradability. So number of properties are these materials. When we add some fillers, they show the multifunctionality. In short, we can say that these materials show the enhancement or some properties changing in the properties. And so in short, we can say that these materials are showing multifunctionality. And before going to see detail about that, so here now this slide show also some application of this polymer nanocomposite material, and these are the different field where we can use these polymer nanocomposite materials. And as we know, polymer have played an integral role in the advancement of drug delivery technology by providing the controlled release of the therapeutic agent in constant doses over long period. So we can use this material for the drug delivery. Now there are some high performance materials are also there, and in that case for energy storage, bio-based polymers, fire behavior, and fire retarding mechanism is there. So there are some high performance materials or polymeric composites materials are also there. Now, in case of the biomedical materials, we can say that bioactive glasses are there, fibers are there, biomedical dental applications are there. So we can say there are number of fields where we can use this, and but these are the major field where we can use this polymer nanocomposite. It is also possible that electrocatalysis is a catalyst that particulate the electrochemical reaction and enhance the durability of the platinum-based electrocatalyst. So this can also be useful in an electrocatalyst. They can also be used as a sensor and graphene polymer nano graphene. These sensors and also graphene with the lignin polymer or oxide sensors are so they are useful for different purposes, and also electrode material. So these are the some field where we can use the polymeric nanocomposite material. So our today's focus is now only on the rubber. So here out of the 100% rubber, the rubber industry use 65% of the total rubber, and these are the some applications being shown in the pictures that rubber mainly used for the tire, and therefore 65% of the rubber used for making these household things and mainly for the automobile tires. So here number of applications are there. So this rubber can use in a automotive aerospace material, in case of thermal insulation, electrical electronics material, smart materials are there, brake material also can be used in a paint and coating. Now whenever we are using all these rubber materials, the elastic module and durability is important in case of natural and synthetic rubber, and it is having high enough fulfill the requirement of different practical field. So what is now, if you concern with the natural rubber, then it cannot fulfill all the requirement. Therefore, reinforcement of the rubber is very important, and therefore we have to add some nanofiller in that material so that we can improve the mechanical properties, thermal properties, electrical that is the environmental properties, and some more properties are there that we can enhance so that it is useful to the society. And in the next slide it is shown. So what are the different nanofiller for the reinforcement of the rubber? So carbon nanomaterials, carbon can be used, filaments sometimes we can also use, silica is generally used as a silicate and also used, and here other some materials are shown here. And addition of this nanofiller in the rubber matrix, they show the improvement in the mechanical properties, that is elastic module tensile strength increases, abrasion resistance also show the increase, and hardness also show the enhanced elongation at break, thermal stability, flame retardance, dielectric properties. All these are the properties. It depends upon the, so important parameter in this case is that in the reinforcing the efficiency, particle size and shape, surface characteristic. So all these are the rubber filler interactions is also important for in this case. So different, we can use different filler in the rubber matrix. We can also take the synthetic rubber, we can also take the natural rubber. So these are the parts. So when we are concerned with the silica as a nanofiller and introduced in the rubber, then what is the now green tire is also synthesized in the Europe for the, and they are having very good properties that they decreases the rolling resistance, increases the abrasion resistance and weight transaction, which give the decreased greenhouse gas emission. And this type of tire is known as the green tire, and this tire is shown here. This is the awesome tire, which is made in the Europe, known as a green tire, and this is the reinforced material used here by the use of nanofiller and increases their properties. And here in this green tire, now this showing this moment and decreases the abrasion, decreases the rolling resistance, and it is because of the addition of this this silica as a nanofiller in this awesome tire, and addition of this silica as a reinforcement material. They show the dispersion and interfacial interactions. So here two figures have been shown here, that here is a filler aggregations are there, and when we add the rubber in the rubber matrix some nanofillers, they show uniform dispersion is there. So this is the difference. There is a filler aggregation, but after addition they show uniform dispersion. So we can use so this indicate that we can use the nano silica or nanocarbon, nano antimony oxide as a filler to enhance the properties of the rubber matrix. Now there are two types of material, and in this case rubber is nothing but the versatile material and used for the construction of wood to the wood, as after proper compounding and vulcanization various products are there, and they show the some properties: flexibility, elasticity, toughness or hardness, stretch, rebound, abrasion resistance. All these are the properties of, related to this. And mainly there are two types of rubber: natural rubber, synthetic rubber. Reclaim is there, it is the final product. So what is the mainly there are two types: natural and synthetic. Natural rubber are known as elastomer, that is, it is nothing but the hydrocarbon polymer, and because of it high elasticity, and this thick stretchy white liquid which is known as latex. Some suspended solid particle may also there as impurities. So monomer in this rubber can be used as is a isoprene in case of natural rubber. These are the some areas here shown figure, that is the pieces of natural vulcanized rubber in first one, and in the second show how the latex is collected from the rubber tree is shown. And rubber tree is a plantation generally found in Indonesia and Thailand. And here we can say that natural rubber are also called the India rubber. Latex is a kanchu, as initially produced, consists of polymer of organic compound isoprene with minor impurities are there as organic compound and some water. Thailand and Indonesia are the major producer or leading country for the rubber producer. And in this case, these are some properties of the rubber. And synthetic rubber is also the artificial and man-made rubber, which is industrially produced by synthesizing from crude oil or petroleum and some other such minerals as a byproduct. Main property of this material is the elasticity or deformation under stress or extreme force, but it is also has an ability to return to the original shape, so without any permanent change or damage. So butadiene rubber are known as a most elastic rubber, and copolymerization is possible by taking the two compounds or two monomer. In case of the styrene and butadiene, butadiene rubber is there. In presence of catalyst, we can form the rubber, synthesized rubber, that is elastomer. And styrene butadiene rubber is the can be synthesized in the laboratory, and purpose of to make this rubber only for the tires of automobile. And also it can also be used as an adhesive for the shoe sole and also floor tiles. So here these are the some pictures of the this rubber where we can use. So as a rubber tube, rubber bands, or some small materials useful for everyday life. And these are the tires mainly used for this making the automobile tires. Now we are discussing SBR rubber. So in this case, this is the one procedure is shown, flow chart. And in this case, hard rubber, which is used for the sole and sole of the shoes, also for tire threads, and also for the places where durability is important. And copolymer, that is also known as block copolymer. And here we have to take the butadiene, 1,3-butadiene, styrene, and this is the monomer tank. We have to polymerize, that is nothing but the emulsion polymerization. And here monomer recovery is also, if some monomer is left here, then it can also bring to the original monomer tank. And after that we get this, after reaction we get the latex, and coagulation is taking place, and we get the SBR rubber drying after that. So this is just one of the flow mechanism how we get this material. Mainly, we are going to discuss here the styrene, betadine, rubber. So these are the materials. As a rubber sheets, this is rubber tire, SBR rubber, and these are the shoes. Sole is there at the bottom, and so this is the material shown. Different colors are there. We can also add some pigment, some color pigment, so we can get also rubber sheet of the different colors. And so now this is possible by using the emulsion polymerization. This is a very good method for the polymerization. And by using this method, colloidal polymer particles disperse in a continuous medium, and most oftenly the water. And this polymeric dispersion also called the latex. And polymer particles are mostly the spherical, which is shown here. And average diameter is 80 to 300 nanometer. And we can say that more than 1 order of magnitude. So polymerization is taking place, and CMC, that is micelles also form. That is a critical micelles concentration. So here, in this way, this is the one figure shown after polymerization in presence of the here the monomer polymerization undergo the polymerization emulsion, and in presence of water. So this is the spherical particles, which are the polymer particles are there in spherical forms. And in this is the arrangement of the particle we after getting the material. And in this case, it is shown this emulsion polymerization material useful for the what is the also known as sometimes radical chain polymerization, and it involves the polymerization of monomer in the form of emulsion, that is colloidal dispersion. And so here how the arrangement is there. See, the monomer droplet one is there, here is shown, and from this we get micelle formation. See, here it is shown. After polymerization, we get this type of material. So this circle with the thread shows the surfactant molecules, and the red color shows the initiator molecule. So after polymerization, micelles are formed, and after that polymerization, we get the this final product of rubber. So this is some mechanism is shown here. And for making this, we can use some materials. So as a activator, and also these are the chemicals used for this stearic acid as a activator, TMDD as a accelerator. So different compositions we required for this. We can also use the carbon black. We can also use some nano antimony oxide, aluminum oxide, tin oxide can also be used as a nanofiller. These are some methods of characterization. After synthesis of this rubber, we can use the these are the methods of characterization, whether it is in nano size, and also what is the nature of that material, and some mechanical and thermal properties. And so here, how to synthesize this SBR nanofiller composite material. So in this table, it is shown synthesis of SBR nano composite material. So 1, 2, 5 composition we have taken different, and here SBR in all the case is 100 gram, and nanofiller we have changed 0 to 6, 10, 12 PHR, and this is the zinc oxide 2 dithiobis TMTD as a accelerator, and the activator are added. After making this composition shown in the table 1 or 2 composition, we can prepare the different 5 rubber sheets. And how to prepare after making this compounding, after making this composition, this is the instrument is shown, and which is known as the 2-roll mill. Here in the first figure, 2-roll mill is a very important instrument for making the rubber sheet. So here are the 2 sheets are here. Here this is the rod shown here in the picture. Another same rod is here. We have to take the that mixture, and we have to put it here. And this there is a some 10-ton pressure is there. After setting the temperature and the pressure, what is this roll? These 2 rolls are moving, and when we put the solution, then we get the rubber sheet. And the rubber sheet obtained in this case is a rough sheet. So we have to finish it by pressing, by using the hydraulic press here. And this is another compression molding machine, which is known as. And this vulcanization of rubber can also be taking place here. So in the rubber, this is the sheet. Here is the die. Here we have to put our sheet, and then we have to press it. And after that, after pressing and applying the hydraulic press of the 10 ton or 5 ton, then we finally we get, after pressing, we get the final product of the sheet of the rubber, and which can be used for our tires or for any other purposes. And so this is the these are the some reactions shown here by taking carbon black as a nanofiller, rubber chain, SBR carbon black. This type of chain is obtained. Another antimony oxide composite can also be synthesized. So how they are combining through the here this pillar can join in this way to the rubber chain matrix. They have been shown here. This is the nano alumina oxide sheet, and where the rubber chain is here, and how they are forming the bonding shown here, which can be confirmed on the basis of the, and this is another tin oxide can also be used, and how they combine with the carbon. So they have been shown here. And these are some physicochemical methods, mechanical spectral studies. Some environmental properties can also be carried out. Thermal analysis also shown here. And in this case of elemental analysis now, after percentage of carbon, hydrogen, nitrogen, oxygen, sulfur, theoretical and experimental values are shown here, observed value and calculated. And in case of pure SBR, when we are adding the filler 2 pHr or 6 pHr, 10 pHr, 12 pHr, they show after that calculated value and observed value. In all the case, they are found very close to each other, and their empirical formula is shown here, and their empirical formula weight. So we can say that synthesized composite materials show some that is the with the calculated value matches the percentage of carbon, hydrogen. So we can confirm the presence of this element in our compounds. And this is very important table which shows the some properties, and here tensile strength is shown, showing increase, and also here shown elongation at break also increases, tear resistance also show increase, and abrasion resistance show the decrease from as the concentration of nanofiller increases, they show the decrease here. But in case of cross-link density increases with the increase of nanofiller. So now here, in this case, this is the tensile strength, and when we measure the tensile strength, we should have to first of all we have to cut the rubber sheet in a dumbbell shape in this way, and then we have to here this is the instrument to measure the tensile strength. And now here we have to put this sheet here, and we can also measure elongation, also we can measure the strength. So here, as the concentration increases, it is observed that as the concentration increases, tensile strength also increases. And this behavior can be explained, that we can explain by the introduction of nano field particles in the rubber chain or rubber matrix. They form the rigid structure, and better therefore they give the better a good tensile strength. So these are the instruments we can measure this tensile strength. This is the graph which shows the increased value of the tensile strength. So see, slight increases are there, and slight again the increase is there. So as the concentration of nanofiller in the rubber matrix increases, they show the increase, and rubber chain in this case show the some layers resulted in the increase in this. So there is an inculcation of rubber chain into the layer, and therefore increases the tensile strength. Another reason is that the enhancement in the properties occur because of the higher polymer filler interaction as compared to the filler interaction, and because of that tensile strength increases. So this is an important property. Now next after that is the here we can measure the elongation property by using same, and as we know, elongation property increases with the addition of nano antimony oxide content or nanofiller content, and this is due to the diffusion of very fine nano antimony oxide particle through the rubber chain, and therefore it supports the rubber chain to enhance the stretching, which reflect on elongation. And so here this is the graph is plotted between the carbon here, and show the increase, elongation increases continuously. Table also shows that there is an increase, see the values increases. And now so the elongation at break increases with the increase of the percentage of filler, and the increase at higher loading is due to the enhancement in the rigidity of the material, because some of the gaps is occupied by the nanofillers, and therefore they increase as the elongation property. So this is another important property. And after this now, so here it is shown in this graph how the elongation is there. And now next property, that abrasion resistant property, and this is shown here, that addition of nano antimony oxide or nanofiller in the rubber matrix at 2 pHr, the weight loss of rubber is constant, and at 10 pHr, weight loss on the addition of rubber, that rubber show the decrease due to the nano antimony oxide act as a filler which not contact with the abrasion load. So in case of 12 pHr, and that is the fifth number compound, weight loss of rubber is again decreases until it reaches the 10% of the nanoparticle will be restricted weight loss. So there is the interaction of exploitation of the filler increase the surface area, and therefore loading up more interaction between the filler and matrix is there, and because of that the abrasion resistance also show the decrease. So here this is the initially some constant are there, and then it decreases, and because of this more rubber matrix and the filler interactions. Another important property of this rubber is the swelling property. As we know, polymer dissolution in organic solvent is a slow process where low molecular weight liquids diffuse slowly into the polymer matrix. High molecular weight polymers, including the rubber, show swelling when immersed in the low molecular weight liquid, and so some changes are there. But now in this case, we can say that the magnitude of swelling and the ultimate dissolution depends on the solubility parameter of both the materials. So swelling ratio of a cross-linked elastomer show the direct measure of the cross-link density. So this is an important parameter, and smaller the ratio, higher the degree of cross-linking density. And enhancing the degree of filler, this enhancement is due to the filler polymer interaction is known for the ability to restrict the swelling ratio. And therefore, value of cross-link density were calculated by using the toluene as a solvent. So highly bonded system has also have high cross-link density with the addition of antimony oxide as a filler, and a cross-link density increases. So addition of filler, we can say that they show the enhancement in the properties of this mechanical, and some properties are there. Another important parameter is there, that is the we can say that ozone resistance. So in case of that ozone, it is when it is placed in the a chamber, what is the in the presence of atmosphere, then controlled concentration of ozone and temperature, then it is observed that or we can say that samples when exposed to the ozonized air, then they show some observations of the surface of sample were made for the crack initiation. Sample were exposed for the longer time, then surface of this material show irradiated sample were scanned, and some results have been shown here that SBR samples cracked within 4 hours of irradiation, and propagation of this is faster, and SBR rubber nanocomposites vulcanizes show better resistance to ozone due to the polar nature. And within the first 4 hours itself crack were formed, and this crack is shown in the next slide, that SBR, we can say that SBR nanocomposite at 2, 6, 10 and 12 pHr show the nano antimony oxide as a loading. Cracks were developed only after the 5, 6, 7 hours. So these are the some ozone cracking shown in this way. This is the nature of ozone resistance shown in this slide. So they take some time, and addition of this also they show the increase in the time for the cracking. This is another nature of the material ozone irradiated surface of the rubber, and after 4 hours the cracking shown here. But now it is increases by addition of this material nanofillers. There are some less cracks are there, so time get long, and that is the takes more time for the cracking. And in this way we can say that sample shows some better ozone resistance as compared to ordinary rubber. So there is it is because of the greater hindrance to the progress of fracture front experienced due to the uniform distribution of the antimony oxide or filler in the rubber matrix and improve the rubber filler interaction. Because of these two regions, they show some different behavior. So these are the irradiated surface of SBR rubber nanocomposite material at different pHr, 6 pHr, 10 pHr, 2 pHr are shown here, 12 pHr. So different natures, we obtain different types of nature of this material. Another important property is the flame resistance, and as we know, flame resistance of the vulcanized of this antimony or filler and SBR rubber nanocomposite is evaluated, and some result have been shown here. And we can say that SBR antimony oxide nanocomposites continue burning after the burner flame application, and flaming drips ignited the cotton places below the specimen, but look more time to complete burning than is pure SBR. So pure SBR and with the nanofiller material, they show some changes, and which are shown in this table. That is only SBR, they show the dripping slow. SBR with 2 pHr also shows slow, but in antimony oxide with 6 pHr, 10 pHr show yes, there is a dripping, and burning is also in the beginning. In pure SBR, burning is yes, there is burning, but little burning is there when we increase the nanofiller compositions. After studying all these properties, now some material, this material can also be characterized by using the FTIR and some spectral methods. And here is the FTIR spectroscopy that give the information about the groups present in the compound. And this FTIR, all these spectra is shown in the next slide, that some of the group present, that is hydroxyl group, some of the CH2 group which are present in the filler can be confirmed on the basis of this spectra is shown here for pure SBR, and for the compounding with 2 pHr, 4 pHr, 6 pHr, and 10 pHr. So different groups, whatever the present in the compound, can be confirmed on the basis of FTIR. So this is one of the spectral method to characterize or to know the groups present in the compound. And Raman spectroscopy is an important tool to know the some spectral bands, vibrations are there. And this is the spectra of here, the spectra of nanofiller SBR composite material can be compared, and symmetric and asymmetric stretching vibrations are there, and which are found to be at 2800 to 3000 centimeter inverse, and a stretching vibration of SBR observed at 1666. So Raman's peaks depends on the blend composition. As we know that intensity of the characteristic signal found at 1002, 1300, 1600, and this show the increase with the increasing curve, that is the nanofiller quantity. And so characteristic signals are shown in this in Raman spectrum. So this is the Raman spectrum A, B, C, D shown here for different SBR, and then different compounding with the nanofiller. And so they show some characteristic band antimony with the nanofiller, and rather they show the poor when sample excited. So from this excitation of wavelength of the nanofiller in the sample, and the Raman spectrum having some prominent signal, they show for confirming the stretching vibration of the some groups. So we can say that peaks of SBR assigned to the some groups can be confirmed on the basis of Raman spectra, so on the basis of some stretching. So this is the method same. This is the image is shown, and this image of same what is the nature of material on the surface can be known from the same. And this is the scanning electron microscopy, is an electron microscope, and that image the surface of the sample by scanning it with the high energy beam. So this is the here we have to put the sample here, and then it scan and give the nature of the material on the surface. This gives the surface area on the surface morphology. But now another method is very important, that if we know the particle size from, and it is possible that in case of TEM, when we pass the beam of that high electron beam, and it give the complete whole morphology of the material inside and also outside. So TEM give the clear picture about the material, what is the nature of that material, how we can confirm the particle size. So this transmission electron microscopy is the best tool to know the detail about the our bulk material, and also inside the material and at the outside the material. So this is important part that both the methods can be used to know the particle size of our materials. So these are the nature of the same images shown here. Some of the sporulates are shown here, rubber nanocomposites. So two different resolution these materials have been shown, and it is observed that these figure shows that nanofiller with the sample exhibit crystalline in nature. From this we can conclude that they show some interfacial bond between the filler and rubber matrix. So we can say that here same figure confirm that smaller the particle size of the filler provide a larger surface area for better filler dispersion and interfacial bond between the filler and rubber matrix. So we get a lot of information from the same images, and these are the same images shown how we determine the particle size and morphology inside the material and also on the surface. So we get complete morphology by comparing the TAME images, and as we know, TAME compare the layer of dispersion and give the clear picture of the nanoparticle dispersion. So it is useful tool to know the characterization of this material. Now, in addition to that, also we can measure the thermal stability is very important in case of rubber. And there are, as we know, there are two methods, isothermal and non-isothermal dynamic TGA methods. And by using the sharp Wentworth method, it is possible to know the activation energy at different breaking of the breaks of the in TJ graph. So this is the equation given by Sharp and Wentworth. By using this EA, that is activation energy at particular part, we can calculate. So details are given here, but now by using this, after plotting the graph, which is known as Sharp-Wentworth graph, and this is another method to know the kinetic parameter or thermodynamic parameter, that is the Freeman-Carroll method, can be used to know the again activation energy. We can also compare activation energy obtained by Sharp-Wentworth and activation energy obtained by the Freeman-Carroll method. So EA can be calculated, and we observed that for this also the value are found to be very close to each other. So in case of thermodynamic analysis, what is the thermal, that is what is the activation energy, what is the order of reaction, and some more kinetic parameters, entropy change, free energy change, that is can also be determined, that is order of reaction. It is also possible by using this method we can calculate at particular point. This is the thermogram is shown for all these our SBR and some composite material. So see here slight decreases and then sharp decreases there. So different natures have been obtained for this, and these are the temperature range where they show some break. Here is one break, there is a loss of some material. Here same one, another break is here. So we can confirm the structure and some groups which are going to degrade at particular temperature from the thermogram, and what is the half decomposition temperature. After calculating that, we can know what is the thermal stability of that material, because it is very important for the rubber matrix. So this is the Sharp-Wentworth plot that we have to plot 1000 by T versus the log dc by dt upon 1 minus c. So we obtain this linear curve, and slope of this we have to find from this graph only the slope, and putting the value of slope here in this equation, it is possible to calculate the value of activation energy. So this is the graph to calculate the activation energy from the slope of this line. These Freeman-Carroll methods also another. This is the graph we can plot between the here 1 by T log WR, and here and also in this case we obtain this linear straight line curve, and this crosses the y-axis here. So it gives the order of reaction, and from the slope also we calculate the activation energy. So order of reaction and activation energy can be calculated from the Freeman-Carroll method. So for this rubber matrix and also this compound, order of reaction point to be up very nearly the half, and here activation energy calculated for by both the methods are very comparable, not much difference. And this is another graph that shows the from this graph it is possible to calculate some entropy change, thermodynamical properties of the material. So in the last now, here, activation energy calculated for the SBR of this material show very good agreement with each other, and activation energy is high as compared to the, therefore they show thermal stability will also be high. From the result, it is also shown that activation energy of the rubber composite was found to be very high, is high, which result higher thermal stability. And so this is the important part of this. And in case of spectral analysis has been carried out and to decide various functional groups present in the rubber nanocomposite material. FTIR Raman spectroscopy shows the presence of some groups, and also mechanical study, it is concluded that due to better interfacial interaction between the SBR matrix and the nanofiller, they show the higher mechanical properties at a low loading level of fillers. And same and tame images can also summarize that filler particles are homogeneously dispersed throughout the rubber matrix. That is, uniform distribution is there, and thermal stability of the rubber nanocomposites specify that the most of the rubber matrix have good thermal stability. So in the future, now we are going to enhance the properties of rubber nanocomposite by introducing new nanofillers, and by using also AFM of the rubber matrix. We are going to also what is the DMA. We are going to do that part. XRD also for that. What give the result? So this is our feature part. So this is my research group that they are here. All these are my research students, and here on this rubber matrix or rubber SBR rubber, here the Rani Mankar is working on this. She also got this PhD in this part, and she has submitted, and some other students also working on this part. So this is the new part. That is there is a possibility of we can change some nanofiller and we can enhance the properties. So this is a useful material for this society. We can use, we can change the properties, and different purpose. So what is now in cold area, in hot area, what is the thermal and mechanical, all these properties, environmental properties are very important. So this is another area of research that we can also do some work in this part by taking natural or the SBR material for the synthesis of nanocomposite materials. So I'm thankful to organizer here that and I stop here. If any question is there.
Hello. Hello, Gurnali sir.
Hello.
Can I ask something?
Yeah. Yes, sir. Yes.
Sir, what are the applications of polymer composite of SBR?
We have initially we have seen what are the applications of this SBR styrene butadiene rubber as compared to the natural rubber. This artificial rubber, this is synthesized rubber, have number of applications mainly used for the tire, and secondly that we can also make we can use it for the adhesive purpose or for making the shoe sole. We are having some samples of the synthesized rubber, SBR rubber nanocomposite material. We are having sheets. We can also give the color to this matrix, and we can also use it for the making the cabinet of the television also. So this styrene butadiene rubber is very much useful for different purposes, for making that is a TV cabinet, shoe sole, mainly for the tire industry.
Thank you, sir, for giving.
This is Aram. Am I audible?
Yeah.
There was a small query. That is, in the beginning of the slide presentation, there was a mention of crystallinity being increased with rubber. Crystallinity.
Okay. So
I didn't find any reference to it later in the lecture.
Okay. Actually, okay, it is not shown. Crystallinity increases because we are introducing the filler, no? That's why. Only details are not given there about that crystallinity.
Which compound it is?
Hello.
Yes.
Yeah.
One of the early slides it mentions about the crystallinity. Later, it has not been much stressed upon.
Yeah, it is not given.
Yeah, okay. So this is what I want to know, how really rubber can increase the crystallinity. Rubber material is far from
Yeah,
increase the crystallinity, but if it can increase crystallinity is something must be novel. The way it does increase crystallinity.
Yeah, some of the properties like crystallinity and other also, when we are adding the in the rubber matrix some nanofillers, they increases. We have seen number of properties. They show the enhancement, and similarly also the crystallinity get increased. It is shown, but detail is not given here. Okay.
Okay. Thank you for the compact presentation of the highly useful materials.
Thank you, sir.
Thank you. Professor Gurmula.
Thank you, sir. Thank you.
Thank you everyone for joining us and adding more information to our knowledge. It helps us to create our innovative ideas in science and technology. Now I hand over the session to Dr. Atish K. Maldure sir, convener of this international webinar. Over to you, Maldure sir.
Hello. Hello. Thank you, madam. As a convener, firstly, I would like my thanks to Sri Ramji Mahajan sir, who is the secretary of Srimati Narsamma Hiraya Shaikshanik Trust. I express my thanks to the Association of Chemistry Teachers and the President of Association of Chemistry Teachers, Dr. Brijesh Pare sir, for giving permission to organize this international event and invite. He accepted our invitation as a speaker also. Thanks to Sonia madam, Professor Sonia Pinero madam, for accepting our invitation.
Thank you. Thank you.
Hello.
Thank you for the invitation.
And you are giving a very nice information and very nice presentation to all of us. So, hearty thanks, madam.
Thank you.
I also give thanks to Gurnulli sir, because Gurnulli sir is a key person of this event, because without him, this is not possible. So, he helping in every moment of this event. So, I hearty thanks to this Gurnulli sir. I also express my thanks to our Honorable Principal, Dr. Rajesh Chandan Pat sir, because when I express my views about organizing this international webinar, he instantly gave the permission and motivate me for such an event. I also thanks to the participants from the 25 countries. The participant gives huge response to this event. The more than 3,500 participants will be registered for this event. Many of the participants will be watching from YouTube. They are going through this live session. I also thanks to the senior members of the SAT who are involved here and show their enthusiasm about the chemistry and chemistry event. I also thank for each and every participant and each and every support, and at the last, who is always with me, my God. I express my thanks toward my God. And I also thanks to my colleagues, my friend. It is not my colleague. They are not my colleague. They are my friends. My head of department, Dr. Srikant Bansur sir. Dr. Pawar sir, who share equally in this work to organize international webinar. At last, I stop, and as a permission of a chair, I say that this international webinar is over. Thanks, everyone.
Hello, Professor
Hello.
Sonia, madam. Thank you.
Thank you.
Thank you, madam.
Thank you, Sonia madam. Thank you, Paresh sir. Thank you, Gurule sir. Thank you, everyone.
Thank you.
Thank you, Gurule sir. Thank you, Sonia ma'am.
Thank you, Gawande madam also, who
And thank you, sir.
really anchored this program.
Sir, I will be interested.
Gurule sir, we can stop here now. Gurule sir, we can stop here now.
Yes.
Okay.
I am Dr. Sunita Gupta and from APS University, Riva. And
Okay.
I will interested the work with all of you, Gurule sir and the Sonia madam. Sir, my work is in a drug modeling. QSAR, computational theoretical drug modeling. Hello.
Okay.
Can you hear me, sir?
Yeah.
I will interested to work with.
Okay, Sunita madam. Okay, we will discuss about that. Okay, now.
Okay, sir. Okay.
We can discuss about the research. Okay.
Yeah. Okay, sir. Okay, sir. Sir, and I will also present it in a next webinar, international webinar.
Okay.
Okay. Thank you, sir.
Okay.
Thank you, Gurule sir.
Rohini, good. Hello, those are on the Zoom meeting. Hello, they can. Hello, they show their camera on their camera. Hello, madam.
Ji.
So that I can take one picture, group photograph. Yeah.
Okay.
Hello, those are on the Zoom. They can on their camera so that I can take one group photographs.
Dr. Sahab Ali sir.
Okay.
I got
remaining also. Hello, sir. Peter, sir.
Unmute video.
Kindly on your camera so that I can take photograph.
I cannot unmute video. Probably it is from your
I can send to the group. Okay, thank you. I want Mudan sir.
I cannot start a video. It is probably organizers have to
okay, sir. Okay.
Permission. Then I will be able to start my video. Camera.
Okay.
Now I am not able to start the video because of.
Okay, no problem, sir. Okay.
Okay.
Okay, I have taken the photograph. Thank you to all.
Thank you, sir.
Thank you, Gurunule sir, for helping us in such a great manner.
Hello, sir. Mahendra Singh, sir.
Yes, sir. Yes, sir.
Yeah, yeah.
Thank you very much for helping us in such a great way.
Good organized, sir. Very good. Good webinar organized by you. Your
Yes,
college,
sir,
huh?
definitely. It was quite not possible without your help, sir.
No.
Thank you, sir. Thank you by heart.
Mainly, our Professor Sonia Madam is here.
Thank you.
Thank you, Sonia Madam. Meet you again.
Thank you. Nice to meet you again too.
Thank you, Sonia ma'am, for sharing
Thank you.
your expertise with us.
Thank you for the invitation as well.
Yes, Madam gave a very nice presentation on the gold particles. Madam, it's nice, very, very good presentation. And work